And I think we are live. Welcome everyone to the fifth episode of Data Pulse. My name is 𝗗𝘁 𝗃𝗲𝗍, and together with 𝗧cie 𝗽𝗶𝗰𝗀, we are running a series of live streams covering various high-level aspects of the integration between operational and analytical, but also getting pretty deep into certain aspects of this whole data enterprise data architecture topic. And today we'll be talking about data governance, very diverse and not as well understood topic as we would wish. And this is our part of maybe helping with this a little bit. And to start, we want to show you, because the topic is pretty wide and very often it's either seen as only fragments of this are seen as governance, or it's not. A lot of these things have been developed or got maturity not that long ago. So this is a slide from, or an image from Databricks, covering different aspects of data governance in Databricks, which is probably the most mature data platform that's available on the market, together with Snowflake. And this is just the high-level scope: the data engineering, the data catalogs, the data classification, data discovery, data observability, lineage, data sharing. These are many different topics. Also, this data quality, security, access control, many different topics. But what they sum up to, more or less, is how to make sure that your data is accurate, your data is kind of taken care of so that it delivers as much value as it can. And also, how do you maintain some coherency and are able to enforce certain things that you might need to enforce. And these things are, again, pretty diverse. And the demand for governance comes from three primary angles. And these three factors are intertwined. They influence each other, sometimes synergize, sometimes there are trade-offs between those. The most well-known, I guess, and the most immediate, because it reaches us with high urgency, is compliance. So we need to comply with various requirements coming from different areas. Another one is quality. So how much value we can deliver, what output do we produce? Another is efficiency. So how efficiently, at what cost we can achieve the outcomes that we want to achieve. And the governance setup varies from organization to organization. There are different requirements, but one axis of how this can be described in a simplifying a lot is how centralized you are. With high centralization, you get a lot of control and you enforce way more, but this always comes at the cost of flexibility and often at the cost of efficiency. So organizations do it differently. So this is one scale that you can tune. Another important aspect touching the high level of data governance is the challenges of managing and establishing governance in multi-platform environments. Because if you are using a single data platform or a single whatever platform, you are there is always a governance setup integrated with it, right? But if with multi-platform, multi-cloud environment, this becomes even more of a challenge that it normally is, and then you need to think about how can you achieve the same goals and how to integrate these solutions. But before we talk about how it is in data, I want to introduce the difference with the operational plane quickly, because in data analytics, governance is very mature. You are managing a lot of data, very, very long periods of data. In the operational plane, the data governance also exists. However, there is less uniform tooling, less standards, because there is a different landscape, different context, and also different priorities. The operational plane usually focuses on strong consistency, because you are ingesting data into your system. So if you ingest data, don't validate this properly, then you are letting bad data into other downstream consumers, and this has a compounding effect. So transactional consistency is of critical importance. Time sensitivity has a different profile, because you are usually very latency sensitive, because very often you have a user waiting for a response, right? So you need to operate efficiently. But also the capability of time travel is not as relevant. What's most relevant is the current state and being able to execute business processes using valid data. But very often data is retained for a short period of time before, as long as it's needed, but not longer. Often you are hyper focused on security because often you will see a much larger attack surface. You are working with external users, very often a lot of them. And because of this, you are much more susceptible to hostile actors than you would be in a data platform with internal data engineers and analysts working with it. It doesn't mean that there is no focus on security analytics, but here this is of absolutely critical importance and always the first thing you look at. Also, you get a lot of diversity in the systems that are built. There is just much more coherency and uniformity in analytics. And with operations, very often you are working with systems, some of them are 10, 20 years old, and they are still serving business use cases. They are written in different technologies, different framework architectures, and it's not that easy to enforce a uniform governance model on top of it. So what's often done is you enforce governance on the touch points, on the integrations. And if you are using Kafka or Kafka compliant solution for this governance, there are two most mature solutions that have very different approaches. So it's worth to mention the differences. One is Confluent Platform or Confluent Cloud, where you get fully integrated, very feature-rich solution that is the data streaming platform, the central nervous system of the organization. And the governance is built into the platform itself. Another one is Conductor, which is a Kafka proxy, which can work with any Kafka broker and any Kafka client. And then you get governance built into the capabilities of this proxy because all of the movement is going through the proxy, right? So we can do stuff like data quality validations there or maybe some metrics. Yeah, so operational plane is over, right? We won't be going too deep into this today. We'll be focusing on the data platforms that are present in most organizations. Yeah, and we'll start with compliance because compliance is also the most urgent, always. Very often you get a certain fixed window of time to adjust to new requirements before your organization starts getting serious penalties. And these requirements may come from different angles. Every organization exists in a legal framework, a law of a country or a region, but also we might have additional regulations coming from specific industry, specific regulations. Financial industry is famous for how regulated it is, medical industry as well, in a different way, that the regulations are different. You also have, everywhere you have serious privacy-related regulations. GDPR is one thing that I've seen dozens of times. And all of these different sources of regulations, they affect the requirements that will be propagated to the development teams. And to give you some example of this, with data privacy, you might get the right to be forgotten, right? A customer requests to have their data deleted. You need to delete the data. So what about foreign keys of this customer's ID, right? This can be a challenge. PII masking. There is the idea of limited scope of access to PII data. So if you want to test something and use data looking like customers' data in non-prod environment, you need to take care of PII masking. You cannot use like actual PII data. And on the other angle, not privacy, but security. In the credit card industry, you get very strict requirements regarding data encryption in motion, encryption at rest. And also, like you are required to have the credit card data processing component isolated from the rest of your networks. This needs to be isolated very strongly. And in the medical industry, you might be required to have the full audit trail of who accessed a data of a given customer, right? And this is just another angle. So where I'm going with this is that you need flexibility because the requirements, first of all, they are very diverse, and second, they change, right? And what's absolutely critical is the flexibility to to be able to implement new requirements that will inevitably come. And there are a few ways to get this flexibility. The very popular one is policies, which is a flexible way of approaching certain controls. Tagging your data or your metadata, column level access or row level access. This is like the problem of how granular you have control over what's going on in your systems. But for in the privacy spectrum, what's popular is dedicated PII detection tools that will scan your databases, your logs, and detect PII to notify you whenever you might have an issue that you haven't taken care of properly. And in the financial industry, you might see dedicated platforms. AML is a specific problem that's very often used by a vendor-provided solution, where you get all of the AML regulations, which are pretty similar globally, and all of the compliance-related business rules are baked in there. You just need to report your transaction data and your customer data to the AML systems that take care of this. So you need flexibility always, and you need your whole setup to support future requirements. And one of the critical aspects of all of this, and the one that's very often the first one associated with governance, is data security. So yeah, how do we get it? How does the landscape look like?
Yeah, so we can talk on data security, but like people who are curious about AML, it's anti-money laundering, right?
Yeah, say it again.
The AML bit is anti-money laundering. That's the part, right? Yeah, and there's no getting away from compliance as such. The other because if you try to get away, or your organization try to get away from it, there will be some penalties. So the other things, though it's pretty important, but even if you don't implement them, there is no penalty as such in terms of government-backed penalties. But compliance do comes with its own penalties in that way. Let's talk on data security. Okay, so what is data security? Data security is something which protect your data assets, but just not protect, but also enables authorized users to use those data. So two aspects: protecting the data and also authorizing the authorized user to access the data. But which data that authorized users should be able to access is depending on the classification of the data, right? So entire, or like in your entire organization, there would be like on a high level 5 or 6 level of classification that exists, right? The public data, which is maybe your marketing data or something which is publicly available about your organization. Then there's internal data. Internal data could be your like employees PII data or employee tree level hierarchical architecture and things like that. Confidential could be your customers' government IDs or those things. Restricted are those data which is even much more secure than that. And then the secret are your like specific keys that you like, the keys that you use for encryption, decryption, that you do not in any case you want to leak it out. And then the last stage is prohibited data. So you should not be collecting any data which is unencrypted, and let's say credit card numbers, right? So you should not be storing them, and you should not be providing any access mechanism for them, right? So these are on a high level, as we discussed, the different classification that you have. Each classification is basically translates to who can access the data and how you want to store the data. So public data, you just need authenticated users to access the data. You cannot, optionally you can keep it encrypted, but it's like doesn't make sense to have that encryption at that end. Internal data, again, authenticated users only, but standard encryption comes into the picture. Confidential data, RBAC, we'll discuss on the RBAC much more detail in our future slides. But just to give you an idea, what is RBAC is? RBAC is role-based access control, right? So instead of user having permission to access the data, it's a team level role, which is maybe your HR team or finance team or data infra team. So it's a role-based access control, and then a stronger encryption is needed there. Restricted data, you will have multi-factor authentication. We'll discuss more in depth in access control, and again coupled with RBACs. And then you will have 2 levels of encryption. One is transparent encryption, which is your cloud vendors provide, like at the S3 is where you store the data. That encryption which provides, so if someone runs away with S3 related hard disk, right? Your data is not compromised. But then you also have your application level encryption. That's their secrets are again like glass breaking sort of scenarios where you would not need access on that specific thing would be needed. That is where you need secret. So it's a PAM is, I think, an open source thing that provides that access specifically, and you'll store the data, the keys specifically on that HSM related things. Prohibited data, as we already discussed, you should not be storing or providing any access control for, let's say, unencrypted credit card numbers or stuff like that. So that is on the data security front. We'll discuss on the components that we have already discussed in our previous slide. So the authentication and authorization, the SSO and MFA part. So you will have a single centralized IDP. IDP is identity provider. So you can, so like Okta. Okta is one identity provider. So any user that you are creating or any group that you are creating will get centralized and stored into your IDP. Now let's say I am a user, I belong to data infra team. So my user got created as soon as I joined the organization, and a data infra team is created in Okta. Right now, when I try to access any of the application or any SaaS provider or any data that I want to access, right, I need to provide my password and I need to provide a biometric or time-based OTP just to prove that, okay, this is the user and I am the user who is trying to access that, right? So this is the MFA and SSO part that we have discussed in the previous slide. Now in the encryption part, we have already covered the public PMKs, like the platform managed keys, where AWS provider vendors like our cloud providers provide their keys and do the encryption at rest. Then we also have customer or application-based encryption, where you want to protect your data. So you will have customer managed keys stored in your KMS or key managed store or some place like that. And then you have your data, which you encrypt by data encryption key. That data encryption key is again encrypted by a customer managed key. So you will have your data encrypted by data managed key, and data managed key is encrypted by customer managed key. You store your data and data managed key at one place. So anyone who tries to decrypt will use the encrypted data managed key, and then use the CMK to decrypt and get the decrypted result. It's a little complex, but that's on a high level is what we are trying to achieve with envelope encryption. Encryption in transit, so not just the data that is sitting on the hard disk, how do you want to encrypt, but also the data that is moving between the services. So you do not want that data to be compromised, right? So you use MTLS, a mutual TLS, where each service exposes its certificates to each other, and then they talk on that front. Showing the certificates which approves that, okay, this is a service which I can talk to, and then they can talk for the transit part. So that's what we have discovered is on the authentication part, SSO MFA, so that only authenticated users can access the data. That's first part. The second part is then you might need more secure data to be encrypted. Encrypted at rest is always provided by default. You might also need application level encryption. You also need to have encryption in transit. And you can even go much more granular in that. You can have column masking and hashing. So you can have specific columns, let's say the salaries of employees, to be only visible to your HR team, not to other teams, because it will be a violation of privacy. And hashing. So you can specifically mention that anyone in the role of HR can do access these columns, but not all the users. So if any other user other than HR team tries to access the table, either that column specifically will be masked, the column will not be visible or masked, or it will be hashed in that way, right? So that's what on the data security front. We have already touched on the most of the points on this. So just on a high level, we'll try to walk you through. We already discussed the SSO and MFA part. Okta is the identity provider. SSO and MFA is how you authenticate and how you prove that you are the user who have access to that. But now you have proven that, okay, you are the user who has access to that. But what are the accesses that you have is the provisioning part of the setup, right? So, okay, I am Sachin, I work for data infra team, sorted. But now what resources should I be able to access? Those should be done through Terraform, policy via code, right? So you will have all those accesses already available to your account level privileges, and those you can use to use those accesses to give specific Kafka topics, databases, data sets, a specific access for your specific role, right? So on a high level, so just last time we are just same point we are trying to, but the thing is to make it quite clear. First you authenticate, then after authentication you authorize. Authorization is what access that you should be having. Those you should be always defining via code through Terraform, and you can have central policy checks. So let's say if someone trying to give their team or their user a role admin access, you doing PR review, you miss it, right? Then the central policy will automatically blocks it. Similar thing happens at AWS IAM level, where specific resources you will have assume role policies for them, right? And RBAC we've already discussed role-based access. Instead of specific users, you will have the team level roles, such as finance, HR, data infra, and then they will have ACLs. ACLs is access controls. So which resource this team guy should have, which operation, read operation, write operation, and this is the user who should be having access. So ACL is the subset of RBAC, which ACL define the permission, and RBAC is the team level policies to which ACLs get attached. Right? ACL can do exist individually as well, but on a high level, just to visualize, this is how you can visualize access control on a high level. Yeah, and then definitely like auditing comes into the picture, where you have who access your data and how, right? So this is also very critical. Ian, can you walk us through how is this very important to us?
Yeah, and the auditing requirements can come from external, right? This external could be a legal body, a government body. This could be a vendor. For example, Oracle is pretty well known for extensive audits of their customers. But also this could be an internal audit. I think most of us have been or seen a process of internal security audit where an application gets checked, or just we have security people coming in and coming up with recommendations on how do we improve our process. And auditability is all about proving compliance, right? But because it's great if we are compliant, but if we cannot prove this to anyone, then we will not check the boxes that we need to check. We need to have a trail of everything that's going on, everything that needs to be auditable. One of this is access audit trail. In the medical industry, this could be access to data. In general infrastructure security, this could be access to servers, right? Whenever we log SSH into a server, our login gets audited and put in the access log. Another aspect of it is business event auditing, and event sourcing is one of the ways that we can get this, because like if you are running a REST API like application and you are just managing a state of the table, you are constantly updating the state, right? But if you are using event sourcing and you are really publishing events based on which the current state is projected, you get this full audit of everything that's going on out of the box together with this architecture. And CDC is another way you can get it, because relational databases have a transaction log underneath, and tables are a projection of transactions in a way. So even if you are just running a CRUD application and updating a table, all of the changes are still there, and you are able to move them if you need to. And time travel is a bit of a different aspect of it, because it allows you to see the previous state of your datasets, and this is in significant demand, one of the drivers of Iceberg's popularity. And all of this is like auditability is a necessity in the context of compliance, but also in the context of just having a robust setup where you know what's going on in your data infrastructure, in your IT infrastructure overall. Yeah, and audit tables are one of the ways that this can be implemented. This is a feature of Databricks where you get exactly that, like audit of a data access. So this was kind of the foundations, right? This data security, compliance, this stuff was there for years. But right now, new tools are emerging. Right now, I mean, the past few years, we were getting new tools, and data sharing has come to a lot of prominence, and modern platforms support it in a very efficient and clean way. The question is how.
Cool. Yeah, so this is very interesting and a step forward in the direction of data governance. So let's quickly try to think, what do we need in data sharing platform, right? So we do need our data to be almost instantly available to the consumers. You do not want to do extracts on the data, and that extract becomes stale. You want to share the data live or near real live data. You also want to have governance on that part, and you also do not want to pay too much on that specific things. And interoperability, you also want to, maybe your consumer data is in AWS and you are in Azure, Google Cloud, or different regions and things like that. So data sharing can be anything, right? You could be sharing to your consumers who's using for training ML models or whatnot, right? So these are on a high level a data sharing platform should have. Let's see how does it have those things, like what are different school of thoughts available there, right? So we have two school of thoughts available in this. One is pure zero copy or near zero copy. So in pure zero copy, which is your Snowflake and Conductor's way of doing things, so what they do is there's no data file will ever be copied from your provider account to your recipient's account or consumer's environment. Whereas in your near zero copy structure, the consumer can directly download the relevant data files to their environment, right? So let's just quickly try to think on this. Snowflake so you have a provider account and you have a recipient account. Provider account has certain tables that he wants to share it with you. So he just create a share object, share those pointers to you, and you also being on a Snowflake, that the logins get the pointer to that particular database. You don't get the file, you just get the pointer to the actual data, the authoritative copy that already maintained at the provider level, and you can run those queries on that. Because everything at Snowflake, hence the governance is also very fine controlled at Snowflake, because it can very well control what data that you can access. But because the other way, where the consumer downloads the data directly, right, that's the problem. Because you can have governance till the data is available at the platform, but once the data is downloaded, then it's at the mercy of how the consumer will work with that data, right? So that's on the governance part. On the cost part, so there is no egress cost for your pure zero copy, because actually there is no data movement happening across, right? It's just even if you have like a different customer account, it's still there is no data movement happening. But with your near zero copy, you're downloading the data. Hence, downloading the data, hence provider will have to pay the egress cost. And egress cost is a very big factor, the get and put object cost, right? Hence, there's a Cloudflare R2, which is a similar S3 bucket, similar to S3 bucket, and they have zero egress cost. So the major blocker with using near zero copy is because it's much more open, it do not provide vendor lock-in and all those stuffs. But the only blocker till that point was egress cost. Now use Cloudflare R2, which eliminates the egress cost. And because egress cost is eliminated, hence it's almost comparable in the cost front as well, right? So that's how the data sharing tools work on a high level. And then we do have this data catalog, which is pretty interesting, has a lot of use cases right now coming up. So yeah, Ian, can you walk us through?
Yeah, and it's cataloging is not really a function of governance, but it's a new, or not really new, but an emerging tool category that helps a lot with this. Because I thought they were pretty new, and then I've read that they've been since the 1980s. But there is a new kind of generation of these tools. DataHub is one of them. The Open Metadata is another, and there are multiple proprietary solutions. And what it is central hub to manage your whole data estate. So application with a UI that's integrated with all of your data sets, all of your data processors, and whatever else, identity management as well, that supports many different functions that kind of is tailored to help with overseeing data governance. And these functions are listed on the screen, as you can see, and discoverability more or less is you are using metadata to facilitate the search problem. If you are working with a large enterprise, then you might have thousands of data sets. And then, yeah, this is just a single place where they are cataloged. Then there's data observability, which is a bit different, because to have data observability, you might need to plug into the runtime or have a runtime integration in some way. In the context of data analytics, this will be at least getting some column summaries of the jobs you're running. And there are dedicated data observability platforms like Datadog that might be much more comprehensive than a data catalog, but still a data catalog will have some observability capabilities where processors are reporting the current status. And on the observability aspect, for example, when you are getting column summaries, you might plug in an automated anomaly detection tool that will notify you whenever at certain point after the last deployment, you're getting a lot, like a very different distribution of data, a lot more outliers. And this is one of the tools that kind of consume this data. Another aspect that's big for data catalogs is data quality, and we'll get into this, I guess, right after that. But yeah, you want to run quality checks somehow, and the tools differ in the way they provide this capability. Data lineage is another. It's the ability to track lineage from the moment it gets into your systems and what transformations it goes through. Access control is often visualized, rarely controlled, but I've seen this documented as well, that I think one of the retailers have built a custom plugin for Data Hub that allows them to execute access control from Data Hub. Data stewardship, so the less glamorous tasks of data classification or just checking whether everything is going fine and tagging stuff. In the data catalogs, you might see features that are supporting this, maybe giving you suggestions on what data, on how should this be classified, or maybe reminding you of certain tasks. And very wide area of features. And the way I see the data catalogs is that they kind of enable certain aspects, and data products and data contracts are very often built into the solutions, and data products are a new way of building things, right? So with this more advanced tooling, you get new possibilities, which are not really new because you could do it without them, but this would be way less efficient. And this is where the value proposition of data catalogs centers around is productivity, right? First of all, you waste less time, less money on analyzing stuff, so direct cost savings. Another one is that if you diagnose an issue instead of 6 hours in 1 hour, this means that your output is affected as well, right? And it makes data collaboration easier, working together on the same data sets, and there are often tools where you can exchange information, like comments and so on. Yeah, and all of this kind of brings you the next level of capabilities regarding data governance, especially in multi-platform environments. Because very often, if you are working with a single platform, this is great because all of the governance aspects are built into the platform. But in global corporations, you might see situations where one part of the organization in Europe is working with Databricks, but also in South America they are using Snowflake. And yeah, how do you the challenge of having a single plane of visibility into all of this? This is kind of the problem that data catalogs are also addressing. And there are two open source data catalogs that I want to mention because they compare really nicely. One is Open Metadata, another is Data Hub. And Open Metadata is simpler, much easier to run, lower total cost of ownership, unless you need to customize it very deeply. It's composed of a web application, of a relational database, Elasticsearch, and Airflow, and this is it. However, with simplicity comes the trade-off of being less flexible, more opinionated, and less code-centric, right? It's an API-first approach, so you enter the data by default into the web UI, or you create your own Terraform providers that will do it for you, but it's not as native to infrastructure as code as Data Hub is. And Data Hub is significantly more complicated. On top of what Open Metadata has, it also has a Kafka dependency. It has a Neo4j dependency, which is a graph database. And also, instead of using Airflow for ingestion, they have their own custom solution that's built into the system. So it's much heavier and more complicated to run. But with this comes a lot of flexibility and much better. It's much more customizable to if you want to have a very flexible solution. And they also champion the code-first approach, and they have their own specification of defining data contracts. So you don't need workarounds to introduce this approach. And one of the core aspects of data governance that data catalog facilitate and make much easier and more efficient is the data quality. And these two products do it differently. Open Metadata does the data quality checks execution on the data catalog side. However, Data Hub doesn't support it. It relies on external tools for reporting data quality, which is, I guess, more enterprise-wide approach, because everybody has this already, right? So how is this done, Sachin? You have hands-on experience with this way more than I do.
Yeah. So let's first define how do you measure the quality of your data, right? What are the things, if exist in your data, you will say that you have the proper quality of the data that you collect. So like these are the few parameters that you should be evaluating just to understand whether your data is proper or not, like the data quality is doing well for your side or no. One is accuracy. So it should exactly match the reality. So let's say if your credit score is 850 or 900, all right, so it should exactly match that. It should not change in your system. Validity. So your emails like example@email.com and example@.com. So example@email.com should exist and example@.com should not exist, right? So those validity should be there in your data. Timeliness should be there in your data. That you should have SLAs and SLOs. SLOs is more internal. SLAs is what you explicitly expose to different teams who are consuming your data. So you should meet those SLAs. Completeness. Let's say if you expect a specific number of orders on a specific day, let's say Friday, Wednesday, those orders should be in that quantity. And inside that order, let's say for an order, the shipping address is missing, then the order is not useful, right? So the orders should be there as expected, and the important attribute inside it should not be missing. Standardization should be there. So let's say one place you are mentioning customer ID is C_123. At other place you are mentioning just 123. At other place you are mentioning CUST_123. So you should have that standardization across. Uniqueness. So as in the real world, the things do not exist in duplicates. The same should replicate in your system as well. So these are the high level pillars that you should be thinking when you should be thinking about the data quality as a whole specific paradigm. Now let's see how can we achieve that. So let's say you have an operational plane directly talking to your analytical plane. At your operational, we have already touched on this. Shift left the responsibilities. So use data contracts, where you will have schema registry or schema architecture, which will have what are the fields needed for this particular data set, and what are the D types, whether this column is nullable, not nullable. So those things will exactly give you the structure of data that you should expect. And if it do not follow that structure, move it to DLQ. And you can set up a PagerDuty alert on the DLQ topics if you see that DLQ topic is increasing. So these are the things that you can set up.
Much easier to prevent issues earlier, right? Than
that's
to
right. Then try to solve it downstream
and clean it up in analytics.
Always. And you can also set up like data contracts that your total order value should not be negative or things like that. So those things you can put that at left side so that the bad data do not tries to enter into your analytical system. And once you have that, right, and also you can set up a streaming lag monitoring. So let's say your Kafka consumer is lagging behind, you can set up PagerDuty alert and paste the on-call data guy or whatever, right? So you should know that, okay, the SLA is not breached there. So now you have made sure that there is no bad data entering, the SLA is not breached. Now the data has reached your raw layer, bronze layer, or whatever you may say, right? Now you should have SLAs at your bronze layer or raw layer as well, right? So that the data get processed properly at on time. So current time minus the data that you have processed last is what your SLA is. You should define that. So let's say you should say that 99% of my time, I will have SLAs under 1 hour or things like that. And you should set up like either if you're using Airflow, Databricks, or whatever orchestration tool that you might be using, every tool provide this SLA setting property. Now you have made sure that SLA is properly set up, the data is reaching timely. Now again, the regex pattern you can apply. again, the same example @email.com, example@.com should not exist. Try to set up those test rules using regex. Completeness. So either we use great expectation, DBT expectation, or whatever. Everything provider tests on row count validation. So it will analyze a pattern that the number of rows they are expected to receive on each Fridays, and today you have received less. So that should get notified. Null rate count across columns. This is the test also should get notified. Consistency. So again, like that CUST_123, C_123, all those that nomenclature that you might have across for a customer ID. So DBT test and also great expectation provide a referential integrity test across different tables. So you have customer table, order table, and you want you do not want any order to be raised by an orphan customer, not existing customer data. Hence, you can raise a referential integrity test across these tables. You can also have centralized reference data. Let's say country, California, USA, or things like that are centralized at one place so that everyone do not have their own nomenclature, and you always join that specific things. Uniqueness should always be there at the silver layer side. So at raw layer, bronze layer, you just append only, and then at silver layer, you do the deduplication on either row number by that specific key and stuff like that. So those are the data quality checks on a high level that you should be having, and this is how to achieve that, right? There are two very famous tools right now in the industry for data-centric thing. One is Great Expectation, and the other one is Monte Carlo. They have two different school of thoughts. So Great Expectation is dependent on the user expertise. That user knows best what validation rule that he needs to set on this pipeline. So you set up those rules, and the pipeline will fail if those rules do not meet. It will also give you a data document for the reporting. The other school of thought, which is Monte Carlo, do not depend on the user to set those rules. Instead, it automatically, depending on the data pattern that it has seen till date, it will automatically give anomaly detection. And it's a very low-level configuration that you can set up for all the tables instead of defining the rules that you need to set up. But then both have its own use cases. You can go very granular in Great Expectation, and Monte Carlo will give you, let's say, anomaly detection or pattern deviation detection or things like that.
And what's cool about this is that you can get more or less automated stuff going on, right? Like I see this too as synergizing and not really direct competitors with each other, just really complementary in order to get as good quality as we can. Another very visual aspect of a data catalog is the lineage graph, and the best way to explain it is to show it. This is a lineage graph image captured from Data Hub that shows kind of the graph of how your data traverses, right? And here you can see data sets. These are the ones with Postgres and Kafka icon. And then the dots, the nodes in the graph, are processing nodes. So processing nodes access data and very often access multiple sources and then output data to their output data sets. And this graph is navigable. So if you have interested metadata about this, you can click on either the processor and see the job definition, or you can click on the data set and see the schema of the table and other metadata that you have either ingested or entered into the catalog. And on a high level, data lineage is the capability to track the journey of data ideally from the moment where it was captured or generated to through all of the different processing nodes and different data sets where this piece of data is used. However, we are not at this level of maturity yet. So in the operational plane, there is rather poor support for data lineage. And the different aspects of data lineage is one is table lineage. This is the easiest to implement. Another is column lineage. This is quite well supported in SQL-based batch processing tools. Because if you have a SQL job, a SQL code, then you can infer which column or table in which column in the output data set is derived from which source columns, right? So you can get this, and this is quite well supported in the most mature solutions. It's not supported everywhere. It's just more complicated, especially not in the operational plane. And the lineage graph is kind of the result of this. And open lineage is something that I've been working with a little bit. it's a protocol that's designed to allow multiple different producers to produce Lineage and different consumers to consume the same language of Lineage. Because what you get right now is that every data catalog or Lineage tool will have their own standard of how do they build the lineage graph. And OpenLineage is one proposition, and it seems to be getting more and more adoption on how can you preserve lineage data and communicate lineage data. And the way it works is that you emit events in runtime, so it's really well fitting for streaming jobs. And when you have a job, you periodically emit the lineage events. And these events can contain lineage data, but can also contain, for example, column summaries, so that, as mentioned previously, you can plug in automated anomaly detection to this. You can report data quality and a few other things as well. Now the semantic layer. How does this work and what can we do with it?
Yeah, semantic layer, right? So I think the one of the feature which all data engineer or data analysts have deeply missed about, so they wanted something like this. So most of the time, the business stakeholders just have the specific metrics, such as sales over day or sales last quarter, and then we have like lot of tables. There is no amalgamation of those business metrics on those tables. So the business stakeholder do not know for this particular metrics which table should I query and how should I query them, right? So semantic layer is one, provide that single source of business metrics definition which sits between your table and your business stakeholders. That's one part. Because all your business stakeholder queries goes through this, so you can have all your governance, like who should be accessing what columns, what rows, and things like that.
The common question that we've discussed is, at what time does your business day start, right? If you are working in retail, maybe you're open after midnight, and then really your work day closes at 2 a.m. So when you're counting sales, everybody in the business knows that the work day means from 5 a.m. to 5 a.m., right? But the semantic layer is a way to put this in code and make the whole data landscape access a single definition of, and there are tons of these metrics, and this is why we get dedicated tooling for it.
Definitely, and that was always a pain that the data analysts used to suffer, because there was no way to satisfy all the business users with the same decentralized definition. Hence, semantic layer is very helpful in that way, right? And also as foundation of Gen AI. So like there are many agentic applications, right, which tries to help you with the query pattern, but then they do not know which table to, again, like the same way that business stakeholders are blocked. These are the business stakeholders, but with more knowledge of SQL, the agentic application, but they do not know which tables to query again. And if you put the semantic layer in between, the semantic layer will tell them that for this matrix, query ordered like sales daily, right? Query orders table and customer table, and query orders table like this, customer table like this in a code level, so that the this guy also, like agentic application, can also make sense out of it, right? So there are different school of thoughts on implementing. Where do you implement the semantic layer? So some people implement them at BI tool level, maybe at your Power BI, Tableau, at that level. Some people implement them at a data warehouse, data lakehouse level, and some people implement them at a centralized visualization layer, not tied with either your warehouse or your BI tool. So the problem with BI tool is, the pros is you're not dependent on a data team, but the con is, because you're fetching the raw data directly in your BI tool and then doing the join and all those stuffs, right? So everyone have, again, the metric inconsistency is there, and you're doing in a language specific to your visualization BI tool. So it's a vendor lock-in as well. Same goes for the data warehouse. Again, it's it's again a golden table logic where you put the aggregated data directly into your data warehouse, but then it again comes with it's as fresh as your last run. It's not very latency sensitive, less flexible. Again, a duplicate storage that you are creating for the golden tables, aggregated tables, right? And then come to your headless BI, which is your centralized visualization layer, single source of truth, not tied with your BI tool or the data warehouse, but then you have to additionally manage, and comes with its own performance bottleneck, right? The two of the centralized visualization semantic layer are DBT semantic layer. So it's a YAML based file. So let's say sales daily, business user query this. It goes to the metric flow. Metric flow uses this YAML file in which you have defined this sales daily, how should calculate, what tables to query, what are the dimensions that I should get the SQL out of it, run it, and share the result to your business stakeholder, right? Running this on a live might take some time. Hence, Cube came with a little more caching layer it provided, right? Using DuckDB, you can just cache them, the faster responses, and all this pre-aggregation is already handled in that way. Yeah, so that's pretty much it on the semantic layer. Very interesting topic on data mesh. Will be very helpful if you can just walk it through.
Yeah, so we talked about like high level and more established aspects of governance. We talked about different, like more emerging aspects of data governance, primarily centered around the capabilities of data catalogs. And something that we want to close with is the like high level, taking a step back and see how governance can be implemented a bit differently. And data mesh is a concept that was put forward, I think, 6 years ago now. And I've seen it more than once called as ahead of its time, because the infrastructure, the IT infrastructure wasn't really mature enough to implement it efficiently. But yeah, maybe now is the time. Maybe now we are no longer ahead of the time. And we see some adoption already. The most well-known ones are Netflix and Uber. But there are many other large organizations doing it. Before I tell you what it is, if you are not familiar, I want to set the context that the problem that this is addressing. And what you see on the diagram is a prevalent approach in many large enterprises where the operational world, running the operational applications, developers and operations are nicely separated into domains that are independent. But analytics is still a centralized team using a single platform and very often being a bottleneck. And yeah, it is distributed into teams and everybody knows like which domains they work with, but they are not working really together with the operational world. And very often in this situation, you'll see this becoming a bottleneck, and you, like the analysts and the data engineers, trying to address and kind of filter out only the critical requirements that they'll be able to implement, right? And this is something that I've seen more than once in the organizations. That first of all, there is a lot of workload on the data engineers. Another is that they are isolated from daily operations. So whenever we get new requirements, they find out maybe 2 weeks later or even later. And then we get a question of why did this schema change? What's this specific field? What does it mean, right? And this is all of this is kind of a result of Conway's law, where the structure of systems it's a result and follows the communication structure of the organization. And most organizations are structured in a way where data and analytics are a separate kind of reporting chain than developers building operational systems. And data mesh is kind of a way to address it. And another benefit that this brings is that with this closer integration between different functions, you get more agility. Because the problem that's there is that very often there is additional latency that can be optimized. And how this is done is organizational change, like a social technical change, right? You need some tooling to support the new approach. But this also means that you need to change the organizational structure. So this is a significant effort because one idea is how to do something best, and another idea is how to convince people so that everyone's on board. And not everyone likes organizational change because people have different incentives often, and this is something that needs to be navigated pretty carefully. The way it works is that the reporting structure changes, and you have domains that are more or less independent, and they are building their own data products. And whenever domains need to exchange data, they kind of create data products on the boundary of the domain. You still have a data platform, but this data platform is self-service, so that analysts are implementing domain logic, and they are kind of using the platform as tooling. And also an inherent part of this is federated governance, where instead of a centralized or decentralized governance model, you get kind of the governance committee, where stakeholders from different domains and also from outside of the domains, they together they establish certain frameworks, certain policies, but then a lot of the implementation is being left to the domains. Because domains, let's say the payments domain and cards domain will have different requirements than maybe the transportation domain, right? Like different level of different types of requirements, different level of concerns. And that there are 4 key pillars of a data mesh. One is this domain ownership. So you need to make sure that there is accountability, and you also need to make sure that if you are adding new responsibilities, that people's incentives are aligned, right? That people actually benefit from building data products and building this higher quality of data. Another pillar is data products. So treating your data as a product. This means that you are value oriented. This means you like the product owner makes the value decisions, the trade-offs, and they actually have control over it. And also you create data products with a different higher level of commitments in order to provide efficiency, so that you deliver better quality, so that your multiple consumers, because often data is consumed by many different teams, then you get efficiency from putting a little more burden on the producer side. And then there is the idea of self-serve data infrastructure. This is kind of a critical part of it, because in order to decentralize, you still need some common foundation. And federated governance, it works in a similar way and is connected to this concept of data infrastructure, because you have a data platform, and governance is not really a data platform. It's the alignment between different stakeholders that is then propagated and implemented into the tooling that we are using. So this was all of the materials that we have prepared for you today. If you have any questions, this would be a great moment. I would like to thank you all for being here with us. My name is 𝗗𝘁, and together with Sachin Tripathi here, we are running Data Pools as kind of a series of streams around the topics of operational and analytical integration and enterprise data architecture in general. The next episode that will happen in 2 weeks will be talking about stream processing with Янnis Polisos from 𝗵𝗃𝗃, a well-known face, and we'll be talking about different aspects of stream processing. Manju, thank you, man. I'm glad you enjoyed it. If you want to see previous recordings, everything is available on our YouTube channel, either in the videos or in the live section, because some are here, some are there, but all episodes are marked pretty clearly. And if you want to get notifications about future episodes, follow us on LinkedIn. The link is on the screen there. That's the most convenient way we can provide this through a stream. Okay, then. I don't see any questions. One nice comment, thanks. And thanks, Sachin. It was really nice to have this session with you today.
Thanks, man.
And we'll see everyone in 2 weeks. Bye. And